So in Model RealTime, we have now added a hyperlink to the TC editor if the TC contains custom properties. And custom properties are, for example, useful when you're using build variants in as a way to persist your own custom data in TCs. And now it's much more visible that a TC has custom property that you can edit in the code tab. We have also spent lots of time on testing the product on Mac OS, and now we have completed enough testing to declare the user interface non-experimental when used on Mac OS on ARM. So previously we had that as experimental since we hadn't tested enough. For log streams that I think you saw also a demo for in last sprint demo, we have now extended it based on the feedback we got, so you can now use them for writing log messages to files in addition to standard output and error. And this feature is part of the target RTS, so it's of course also applicable for code real-time users. Then we have documented something that has been forever in the product called the RTS debugger. That is the debugger that appears when you start and generate executable without any arguments. For some reason that was neglected in the documentation for a long time, but now we have written documentation, and that applies of course also to code real-time. We have also published a new script, which we call the test runner script. This is a script that makes it easier for you to test if you have a custom version of the target RTS, which I know many of you have. When we release a new version of either code real-time or model real-time, you typically want to make sure that your custom version still works. And this script is based on test cases that we already also have published. So it gives you some confidence that if these tests are still passing with your target RTS, that there are no breaking changes. And this script can be both run as a batch script, for example, when you're integrating it with CI/CD tools, or you can use it interactively while you're developing through a web page. And I will show you that later. Then we've also implemented a new way of tracing, which is quite exciting. So this way of tracing has the focus of producing sequence diagrams to show what happens inside the application when it's running. And contrary to the existing tracing feature, this one is independent of the model debugger. So it's implemented purely in the target RTS, and it captures traces related to message communication, because that's what you show in these diagrams. Right now, we rely on an external web service called JS Sequence Diagrams for visualizing the trace. And you can turn this tracing on and off in a variety of ways, including the RTS debugger, model debugger, even from a C++ debugger, or programmatically using APIs from the target RTS. We also are releasing a new version of the art exporter called 201. You can find it on the info center. This has been completely redesigned. Now it's based on the model compiler, which makes it possible to run it from the command line. And also the generated art and C++ files is now more consistent with what it looks like when you're generating code inside Model RealTime. So previously, this tool only supported data types. Now we support, at least initially, capsules, protocols, ports, events, etc., which means that you actually now can start to migrate at least simple applications from Model RealTime to code RealTime.